realized that during my podcast, I tend to talk about brains a lot, picking at them, exploring them, just sort of basically violating this whole brain-mind space. And I was thinking to myself, why do I do that? And not just why, because it's fairly obvious. It is a very fascinating subject. But more importantly, what am I even doing talking about brains? I'm pretty much a moron who doesn't even have a basic functioning knowledge of how the human brain works. And one of my oldest friends in the world is a tiny bit of an expert in the field. Assistant professor of biology at DePauw University and PhD in Medical Neuroscience. And I can't stress this enough, but just an all-round amazing guy and a damn genius to boot. And I realize now that I have to refer to you as Doctor. It feels strange to see that. Dr. Nipun Chopra. Welcome to the show, man. How have things been? Doc?
Good, man. It's good to be here on with you, bro. First of all, the part where you said, I don't have a functioning knowledge, I thought you were going to say, I don't have a functioning brain, in which that would have been perfect as well. It's great to be on with you. I think you've done such a great job. I've listened to the first 2 episodes. Really great job. As I've told you before, I think you, out of all my friends, you are uniquely suited for this format, for this kind of interaction with your friends.
And I learned from the best, didn't I? Because little known fact, this is not our first rodeo on a podcast. You and I actually started one years ago together. And who would have thought that the lives of 2 people on the same show could go in such different directions? But I think if one person's a Liverpool fan and the other one's a United fan, it's only natural that we would run away from each other.
2011 is when you and I did our first podcast together, Jhala. And our lives have diverged in many ways, but we've also converged at times, right? We worked on Exhale together, worked on a couple of things together. So it's one of those things that, it's not like you and I speak every day or even every month, but there's a genuine affection, at least from my end, which I don't have for a lot of people. So there's a genuine affection and like a reconnection whenever we do talk.
You've seen me naked, so that's genuine connection there.
That's the part of the connection I'm trying to sever.
Yeah. And seriously, I think I really treasure our friendship. Like you said, despite the fact that we're worlds apart, oceans apart, I don't think it changes anything whenever we do speak to each other. And I've been so excited to have you on this podcast, man. And to be honest, you've been this calming voice of reason in this mayhem, in this madness of the world, these menacing times that we're in. There's so much noise. You don't know what to read. You don't know who to listen to. And then you just come. Just for reference, guys, anybody follows Nipun on Facebook especially, please add him and follow his Facebook statuses and Twitter. He gives such a concise, clear, factual breakdown of this whole COVID situation and the world we're in right now. What it means for us, what the disease actually entails, where we are with vaccines, everything you do. I now go to him rather than watching any sort of news outlets because it comes from such a genuine place. And I really appreciate that. I don't think you understand what it actually does mean for people, you putting that stuff out there.
I think this is turning into a podcast where we're just jerking each other off. And that's really weird for us because we're usually just making fun of each other. So this is really weird. Thank you for saying that. I think from my perspective, it started with something you and I know a lot about and talk about is WhatsApp, right? I just saw so much misinformation on WhatsApp in my family groups, in my friend circles about this, about COVID. And I was obviously interested in it. I've been reading a lot of papers, but it wasn't my intention to become a science communicator on COVID. I was just interested in it, and now I'm researching it as well as a tangential thing. But for me, it was just a thing of, okay, these are complete misunderstandings of what's going on. This is a complete misrepresentation of what this is, and that was what started my interest in talking about these things on social media, Facebook, Twitter, as you mentioned, a little bit on Instagram, just to be like, okay, look, we are all in an unprecedented scenario, and I am worried that people are going to use the misinformation in a particularly scary way, right? So let's take, for example, hydroxychloroquine, which is, according to the orange Cheeto, a treatment for COVID-19. And there's there are people in my family who bought into that, right? The people I know in stateside who bought into that. And there's such a danger in taking that treatment prophylactically if you're not under guidance of a doctor, because it leads to cardiac abnormalities, leads to a long QT syndrome. So, it was just a desire to clarify misinformation. And it's kind of morphed into this thing where I post way too much about it.
Okay, yeah. So sorry. So that was a good opening to the conversation, but I really do want to get into what your main area of expertise is. And just
Football,
to read...
right? Let's talk Man United.
Do you really want to talk about Man United? I was looking at your university page to see your profile. And it was like really focused on your areas of expertise. And so obviously there are two aspects of it as far as I can grasp. And one of it is your work in Alzheimer's disease. And of course, I'd love to get into that. And then we can get into the second part of it, which is concussions and CTE, which I think have a little bit more information about because it's so prevalent in sports and a lot of sports that we watch. But yeah, let me know, like, what are you working on? What are the things that we need to sort of know about the advancements in Alzheimer's treatments, etc.?
What I should say is, like, when I was doing my PhD work and my postdoctoral training, I was a lot more that was my full-time job. That's all I did was research and spent 70 hours a week on research, right? Now, my day-to-day job is a lot more professorial. It's a lot more teaching than research. I still do research. But I should preface that before I explain anything. Okay, so with Alzheimer's disease, honestly, the big conversation in the Alzheimer's field right now is how we need to revisit what we think causes Alzheimer's disease, because the treatments we have designed towards that have not worked. And we've tried to design treatments toward that problem in many, many different ways. And they've failed in clinical trials, reaching as far as phase 3 and then failing. So that's the major area. There's a recent report talking about changing diagnostic principles as well. But honestly, if I were to be very skeptical and look at it from the outside, I would say the Alzheimer's field is stuck in stasis and has been for 2 decades.
So is it like, what is it that we don't know? I mean, just to sort of break it down, like, how does it work in a brain? Like, what happens to the brain when somebody starts getting symptoms of Alzheimer's?
So honestly, that's the magic question. And I'll tell you why. So when, as you know, there are some behavioral things that show up. You can do a behavioral test for dementia. You can do some neuroimaging to test for certain things in the brain. But generally, just like all most neurodegenerative diseases, we are confirming for Alzheimer's disease also post-mortem. So you look at the brain of someone that has died from presumed Alzheimer's disease, and you slice it and you look for specific kinds of markers, specific kinds of proteins in the brain. Okay. Now, these proteins, one's called amyloid, one's called tau, and we don't need to get into them in detail. But there are 2 different kinds of proteins that we believe that always show up in someone that is diagnosed with Alzheimer's disease. Okay?
Yeah.
We've known that for Alois Alzheimer discovered this roughly in 1912. So we've known that for over 100 years. So for the longest time, we've believed that these 2 proteins are the reason we have Alzheimer's disease. However, when we've tried to reduce the amount of this amyloid stuff, one of these 2 proteins hasn't really changed disease progression. And the question remains in the field, are these 2 things, which are undoubtedly there, are they there because of the disease? In other words, are they downstream of the disease, or are they causing the disease? And that remains the fundamental question in the field of Alzheimer's disease. And
like, how do people recognize if somebody's got Alzheimer's, in the sense that, sorry, I might be asking very basic questions, but in terms of the difference between, say, dementia or Alzheimer's, or is dementia a step towards Alzheimer's? Like, how does that kind of work?
Great question. So Alzheimer's is one kind of dementia. It is the most common kind of dementia. Dementia essentially just means a change in your cognitive state. Right? It could be a loss in memory, like it is in Alzheimer's. It could be a change in personality. which is one of the first signs of, say, frontotemporal dementia. It could be a change. It could be a change in motor function sometimes, and Parkinsonian dementia, which is a rarer kind of dementia because Parkinson's is mostly a motor disease. Anyway, so come back to your question, how do we diagnose it? So we diagnose it when someone's alive based on these. So if I'm being tested for dementia and you're the neurologist, which is an absolutely frightening thing, you actually look like a neurologist now, to be fair, with your beard as you stroke it.
My beard right now.
But the thought of you being in charge of anyone's life gives me the creeps. So you would ask me questions that would ascertain my memory in the case of Alzheimer's, and my visuals and my skills. Not only memory is one portion of what is called the MMST score, but suffice to say, you asked about 30 questions. And if you score lower than 25, I think it's the 20 or 25 is the cutoff. It's been a while since I looked at this. Out of those 30 questions, you start getting, you may fall into the early category of dementia. And if you get really low, like you get 5 or 6 questions, then you have late dementia, is what we call it. So early MCI, late, anyway. But the point is that there are behavioral tests we do while someone's alive to say they have dementia. And if it's heavily related to memory, it's usually Alzheimer's disease. If it's heavily related to personality changes and depression and gambling, then you go down the route of frontotemporal dementia, CTE, right, which we'll talk about. Yeah. So depending on what kind of route you go down in terms of your impairment is how we demonstrate what kind of impairment you have, what kind of disease you might have.
Is there a sense of understanding when somebody will get that? Do we have any sort of understanding of what those causes are, if it's genetic or if it's just random? Like, how does that work?
So there are actually 2 kinds of Alzheimer's disease. There's the early onset kind, which has a very strong genetic component, but it's much rarer. It's about 5% of all Alzheimer's cases. And it tends to happen to people around the age of 40, 45. Like the ages that you and I are getting to, Jhala, is around the start of where you start seeing early onset Alzheimer's. The more common kind, the one we associate with our grandmothers, for example, grandparents, I should say, that is the way more common kind, about 90 to 95% of Alzheimer's. And the genetic component for that is much smaller. And when I say much smaller, I mean there is a risk factor for a particular protein called ApoE, which we don't need to get into. But to summarize, essentially what I'm saying is that what we think, all of us think of Alzheimer's disease, the Notebook and everything you've seen on TV, that is the late onset kind. And that is a much smaller genetic component. So when, for example, my fiance's dad always talks about how he's worried he's going to get Alzheimer's because his mother had Alzheimer's. And I always tell him, look, your mother got it when she was 75, 80. So the risk factor for you, unless you have that one particular genotype, is pretty negligible. And even if you have that particular genotype, it is a risk factor. It doesn't determine you'll get it. So, I think that's something that I wish more people understand, is that they don't need to be freaking out if people in their family have Alzheimer's, unless it's early onset Alzheimer's.
Okay, got it. So you should still be freaking out either way.
No, but very few people. I've known one person in my life ever. And actually, it wasn't in someone I knew personally. It was a parent of a friend who had early onset Alzheimer's.
Yeah, I don't think I've ever known someone to have Alzheimer's. But then again, I always thought in India, we don't really know.
Right.
Somebody's gone a little, you say, oh, they've got a little kooky in their old age, they've gone senile and they don't remember stuff. But did they have Alzheimer's or not? I don't think it was ever defined. And that comes back to me, like when you spoke about, you were painting a slightly grim picture about how you said the research.
That sounds like me, to be fair.
Yeah, you're saying the research is in sort of stagnant right now and not sort of developing. Because whatever you see and whatever you hear about people from Alzheimer's, trying to put yourself in, and getting away at least a little bit away from the sort of technical medical stuff of what's actually happening in the mapping of the brain. But just from a human point of view, it seems like an incredibly terrifying place to be, to go through, because it can leave you completely disoriented. If you do not even remember the people in your family and stuff like that. I don't know if those are just extreme cases of what it is, but it is a worrying thing that you said that there doesn't seem to be doesn't seem to be getting anywhere in terms of treatments.
Yeah, I mean, I think that's absolutely fair. It really is not the only real effective treatment we've had came out in 1996. It's called memantine, and it treats the symptoms, not the disease. Has a completely unexpected mechanism. It was found completely by accident. So since 1996, we really haven't had a treatment approved for Alzheimer's disease, which is kind of frightening, right? There's been a lot of money, a lot of funding in Alzheimer's disease. The highest amount for the NIH, with National Institute of Health in America, puts up most of its money towards Alzheimer's and cancer and heart disease. And the incidence of Alzheimer's is only expected to rise. As you were talking about India, right? One of the things we know about India is the average population is much younger than a lot of European and Western countries. Now things are changing in India and people are living longer. So we're expecting to see an increase even in India. And we're already seeing an increase in incidence in India. Whether it's incidence or diagnosis is a fair question, to be fair. You know, what I encourage you to think about is that Alzheimer's is actually a disease that affects the family as much as it does the person, if not more. Some would argue more, because some would argue that once you have advanced Alzheimer's, you're actually in a state of bliss where you don't really know, you don't have memory, so you don't have a frame of you don't have a frame of reference to understand what's going on. So it's obviously very scary at the start, but once you have late onset, when you're later on in Alzheimer's, you know, it's almost blissful. And I say that in quotes because obviously it's horrible. Whereas the family has to deal with the consequences of a parent forgetting them. We are our experiences as told by people we love, right? So like for me, I remember things a certain way. Let's talk about you and me right now, right? You probably don't even remember the time where we met, or your story of it must have been so banal, where you just met a dude at a party, right? But for you to hear it from my perspective enriches that moment, right? Now, imagine what you would feel like, and you and I aren't even family, right? Imagine what that would feel like if I were to completely invalidate it and be like, no, we never met, that I don't know you, right? It kind of shakes you at your very core, right? So I think there's an strong argument to be made that Alzheimer's actually, in terms of its impact, has the greatest impact on caregivers and people that are loved ones.
It's so profound the way you put it, and actually made me think of something else. Even though I do want to get into CT and stuff, this made me think of something else in terms of memories.
Yeah. And
just what memories means. You know, for me, it's always been, when you have a powerful memory, I feel like it's only as powerful as that moment that you're living it. And it never holds the same strength 1 year, 2 year, 5 years later. And I've always felt that, especially say in relationships, you know, when you're in love with somebody, that moment, you think there's nobody else more important than you and that person. And you can't even imagine how it could be anything else. Right? And it's such a strong, powerful emotion. And then 5 years later, you look back and you can't remember that moment as strongly, and you don't, and that breaks my heart. Just thinking that I've lost that forever.
And we have likely evolved the ability to separate that as a self-preservative mechanism. Because if I held on to that pain always, and by the way, there are some things called episodic memories in which you can feel the pain a little bit. But if we held on to the emotion and the pain for every single memory, we would not be able to get through the day. The flip side of that is what you're saying. You can't experience that happiness ever again, right? But I think the reason we have evolved this is because it's to protect us from our most painful memories.
Yeah, I think that makes sense, because I don't think I thought about it like this. It's almost like be careful what you wish for. It's exactly. I want to preserve all these memories, but you got to realize what that balance is. One of the connections you sort of made when you were talking about Alzheimer's, especially the fact that you can only sort of analyze it posthumously, kind of has that link with the second part of what we want to talk about is CTE, concussions. And I think maybe it's best for you to sort of explain what that means exactly. But before you get into that, I'll tell you what it sort of meant for me in recent times, especially. Like I'm a huge American football fan. I've always been very gung-ho about wrestling. I remember, were you ever into WWF, WWE?
Dude, I watched it last night.
But it was such a big thing in Calcutta. And I used to go over to some friend's house. I used to have these two Korean twins in my school in CS. And then they would just take turns to body slam me and suplex me and throw me off the top of the bed. And it was just so much fun to be part of that and take one on the chin. And I would watch like American football and I'd be baying for blood when I'd see the clashing of helmets and two people crushing each other. And I'm like, yeah, let's go. And then suddenly, now as you get older and all these studies come out and I'm watching documentaries and movies, and that's where you come in to tell us what that really means. Now I've got a whole different outlook. I'm watching the same stuff and I'm cringing. If I watch a UFC fight, somebody gets slammed headfirst into the mat. I'm like, oh my God, a clash of helmets. It's terrifying because now you know the real cost. And that really comes to what you are doing with CTE especially.
Yeah, I mean, my experience is the same, Jhala. I've been obsessed with WWE most of my life. Like I'm 36 years old. I should not be obsessed with WWE, but even now, like I'll watch it, 4, 5, 10 times a year, right? Speaking of injuries, I was Lamartine, and you know the story, Jhala, but I should share it. Lamartine is was one of two schools in the entire country that allowed intramural boxing. And I was involved with boxing. As you know, I was just like a jock, right? I played every sport there was. One of the sports that I was really good at was rugby. And I was 120 pounds, probably less than that, going up against guys that were maybe not twice, but 1.5 times my weight. You always taught to tackle with your shoulders in rugby, right? Of course, which is the right technique of tackling. And this guy, I remember him coming towards me, and he obviously saw that I was much smaller than him and I was going to go in for this tackle. So I remember him kicking his foot out like this, like how those jokers, like clowns, kick out their feet while dancing. This dude wasn't very fast, of course, so he could afford to do this portion of it. And he kicked out his foot and struck the side of my head. And obviously I went down, but of course the only thing, so I was out, right? I was carried to the sideline. And no one actually cared that I got hurt. That was a rite of passage. They were very proud of me because I had taken him down, kind of tripped him with one hand. And so even at that young age, it became, I was, reinforced to me that it doesn't matter what happens to your safety. You just have to make sure that
you're conditioned to think that that's like a badge of honor.
Exactly.
And you wear that on your sleeve. Yeah. Crazy.
Yeah.
Sorry, carry on.
But yeah, no, so I'm the same way as you. I was a product of that, and I perpetuated that until I was probably after I left college is when I started becoming interested in CTE. One of the things that started that interest is a common story you and I have, which is the death of this WWE wrestler, murder-suicide, Chris Benoit, a Canadian wrestler who's at the time was considered one of the best in the world. I loved him. I loved Bret Hart. He was always my favorite guy. And Chris Benoit was a Canadian wrestler generation below him, just younger than him. And I love Chris Benoit. And I remember reading about the story. This is actually still when I was in high school, but I didn't process it till later, about this murder-suicide. And of course, later on, he for people who don't know, he killed his son, killed his wife, and then killed himself. His brain was positive for CTE. And that, is it. And there have been many other stories.
So what does that mean? What does that mean when you say
positive for CTE? So like Alzheimer's disease, if you look at the brain of someone who has CTE, you'll actually see physical holes in it because the neurons have died. You've lost neuronal mass, neurons. But why it happens in CTE has also to do with one of those two proteins I talked about, amyloid and tau. In the case of CTE, amyloid is very rare and tau is a lot more present. There's a specific kind of tau, a modified shape of tau, which makes it very sticky. And as it sticks together, it kills neurons. It precipitates out and it kills neurons. And those are called tau tangles or neuritic tangles is what they're called. So there's a huge amount of this, and it kind of starts in the part of the brain that's just sitting behind your temple, which is called the frontal cortex and the prefrontal cortex. Now, these are the parts of the brain that you can think of as a brake. This is great. Jhala,
you say as a brick?
As a brake. Like
as a brake.
Brake,
okay,
yeah.
You're braking. Yeah, okay.
You're braking. So think of our experience, and huge oversimplification, you'll have to forgive me, but think of our experiences as, we have emotional reactions to things, right? So when I see your face, I get angry, right? That's a normal reaction for me, right? Whenever I see your face. So I would want to normally, if I was a primate, I might come and try to punch you, right?
Yeah.
But the prefrontal cortex and the frontal cortex tell me, okay, that's not societally acceptable. We need to stop that behavior, right? So it is the brake that the frontal cortex, prefrontal cortex is the part that humans have developed to suppress our normal impulses. Since that's the part that's normally affecting CTE, some of the symptoms you start to see early in CTE are increased gambling, sex addiction, increased addiction to other
vices,
like vices, opiates addiction, heroin addiction, stuff like that. So a reduced ability to fight your own urges is one of the first symptoms you see in CTE. Then you see depression. Eventually, you see a personality, because again, your personality, as we know, it is
protected, and now that protection is kind of unlayered. Yeah,
exactly. It's mostly encoded in this area, again, behind your temple. And then eventually we see suicidality. We see in the late stages of CTE, we start to see memory impairment, because the part that's controlling early memory formation is actually sitting kind of deep in your brain, called the hippocampus and entorhinal cortex. And those are kind of protected most of the time. They're the first to go in Alzheimer's disease, but they go much later in CTE. And they go very, very, very rarely in Parkinson's. So again, these are differences in how these diseases manifest, so that you know which one you're dealing with.
And so how does it come about? Because I'm trying to understand the theory. Is it just your head colliding with things over a prolonged period of time, and then it starts to deteriorate, that frontal cortex? Or is it the brain within the skull just bashing around within the skull, and that's doing the damage? So it's actually the internal movement of the brain and skull rather than the skull on another immovable object.
Well, it's both those things. And one more thing I'll tell you about. So it's also the first thing is absolutely true. You collide with someone, there's impact of your brain moving inside your skull. And they are both vertical forces. They're also gyroscopic rotational forces. As your brain's actually sitting inside, your brain's not actually just sitting in the skull. It's actually like a jelly between your brain and your skull. And it rotates, and as it rotates, it causes micro tears in some places. It causes, if it's a severe enough skull fracture, come back to soccer, if you remember, John Terry against that Bolton defender whose name I forget now because it's been so a while. You can call a bleed in your brain. So, those are all primary injury. Okay, so that's what happens with a concussion. You can get knocked out, and you have to do a specific. You show some symptoms, but there's also a secondary part of this, which is called the secondary inflammation. So, say you recover that first, say you have a concussion, as I did when I played rugby, not diagnosed, I'm self-diagnosing because no one gives a crap.
Yeah, I think we've all had one or two concussions. I remember I got cracked open with a cricket bat in school. I was wicket.
Are you serious?
I was wicket keeping way too close to the batsman for some reason. I don't know what I was doing. And he did a
Jhala, based on episode 2 and what you've told me, we really, at some point, maybe we need to flip the roles here and dive into the impact your schooling has had on you, because I think there's some repressed.
Cricket bat was pre-boarding school. It was in Calcutta and it was an accident. Let me just
gotcha. It just sounds like there's a lot of. I mean, as someone that has a lot of repressed memories and a lot of repressed anger, I feel like we need to delve into yours.
That's a whole other episode. We're just going to talk about our repressed memories.
So there's the primary part, and say you recover from the concussion or the injury from that, right? You can die from that first hit, right? There's a thing called subdural hematoma where the blood collects in your brain and pushes down the rest of your brain through the only space back here. And it's called hemorrhaging, and you die, right? But most people will recover. And then what happens is there's a phase of secondary inflammation. What does that mean? It means that your neurons in your brain, and there are these other cells in your brain, which are kind of like the white blood cells in your body. Okay, they're basically responsible for the immune response, quote, as an oversimplification, in your brain. They're called microglia and astrocytes. When they see that the neurons have got damaged, as what happens after this injury, they start to release factors. Just like your normal body would, it would release cytokines, right, which causes more white blood cells to come and attack the infection. Same thing in the brain. You get more microglia, more astrocytes, and you get an overreaction of the immune part of your brain. And that persists over time, and that leads to long-term damage, which is what then eventually leads to neurodegenerative diseases such as CTE. Okay.
But when you say it persists over time, it's not persisting on that one incident that you've had, right? It's then a series of these clashes.
Actually, let's combine COVID and CTE here to understand what I'm saying. So what happens in COVID is that there's a thing called a cytokine storm. Okay, that's a fancy way of saying that your body detected the virus and produced an immune response like it should have. But then, due to some reasons that we don't need to get into, your body keeps on reacting to the virus. Even if the virus is not there, it keeps on sending white blood cells, which release more cytokine, which sends more white blood cells. And that leads to basically your lungs becoming flooded with blood, which is what leads to a part of what is the ARDS, the respiratory distress syndrome. Okay. Same thing in the brain. After your body, your brain has actually not, you suffered the first injury, your microglia reacted like they should have, but then instead of that stopping, more microglia are coming in over time. More astrocytes are overreacting. They're releasing more factors leading to more microglia. So it's like a storm, cytokine storm inside your brain, which is one of the things that happens, Jhala, is if you have too much of this stuff, your immune cells, instead of attacking a virus, they start attacking your normal neurons. Think of it, another good analogy is, say, there's a fire in your brain, right? So the fire engine comes in, puts out the fire. Everything's good. Life goes back to normal. Now imagine a scenario where the fire in your brain, the fire engine, which are the microglia, comes in. They start putting out the fire. The fire is gone, and you're trying to start your life again in the house, but they'll never leave. In fact, they're bringing in more fire engines and adding more water to the building. It's going to destroy the building, right? So that's what's happening. Again, it's happening in ARDS with COVID. That's happening in your brain with the microglial overactivation.
So just to get that straight, that means you're saying that one incident could affect you the rest of your life.
That's a great question. So the honest answer to that is we don't know. At this point, there is no conclusive evidence linking concussions to CTE. There is correlational evidence, strong correlational evidence.
It's common sense.
As a scientist, you have to be careful, and I should have been more careful. So I really appreciate you clarifying that, because I should have been more careful. So let's take the study that you probably heard about. Came about 3 years ago. Professor Anne McKee at Harvard University was the senior author in this. She looked at the brains of about 120 athletes. Okay, and they were mostly football players, mostly retired NFL players. There were a few MMA boxers, MMA athletes, which is what I studied when I did TBI.
Sorry, when we say football, we should just say it's American football.
American football, thank you. Yeah, exactly. So, by the way, this in a week will be the anniversary of when I moved to the States, exactly half a lifetime ago. Right?
So you're a soccer guy.
Now I say soccer without even thinking about it, even though I used to laugh at it when I was in India. So her study showed that 96% of the brains of NFL football players showed CTE. 96%. Now, if you are someone that doesn't understand the scientific process, you would be like, pull your kid away from football immediately. And personally, I would, but that's my choice. But someone who is a scientist has to give you the caveat, and it is a very big caveat. That caveat is there's a huge self-selection bias in that data. The people, and you know this,
because
Chala,
you're not examining the brains of the people who are not suffered
showing
through the thing or
symptoms.
whatever. Exactly. So then you would never know what the correlation is.
Right. So what we can say, I think what that study showed beyond reasonable doubt is that NFL being a part of the NFL and being actually I can't even say that. What it showed without a reasonable doubt is that being a part of the league may lead to increased chances of CTE.
Yeah.
That's all that should, to be from a perfectly skeptical scientific perspective. Now, when you bring in common sense and you bring in that stuff, I would say the link is fairly strong, but we have to be clear.
I mean, having watched the sport, and for people who don't watch that much, I mean, there seems to be a disproportionate ratio of people who have violent tendencies. Quite a few suicides, murders, domestic violence.
But there's a key pushback to that. And there's a key pushback to that I have to share here. It is possible that there's a self-selection bias in the people who want to play football.
Yeah.
Right. So it's possible that the kind of person that gets to that elite level already has inherent aggression, already has an inherent ability or desire to take risk. Right. So that's why we have to be careful to say correlation here, because it's completely possible that there's a personality type and therefore potentially a genetic type that is resulting in these behaviors, which may be correlated with.
That's actually a great point, which I never thought of, because it takes a certain kind of personality to be brave enough to go, I'm going to go head first and use my helmet as a weapon to go charge at somebody. So they may be sort of conditioned to behave in that way as well. But yeah, I mean, I guess the science is still kind of nascent, because, as you said, you can't really check anything until people die, and that also if they've given permission for their brains, or the family's given permission for their brains to be investigated.
Yeah, that's true. It is changing, Jhali. So there are some studies now suggesting that we may have biomarkers for CTE. There was a recent study about 2 weeks ago that suggested that we may be able to detect this particular protein in the blood. But it's not a robust study yet, and you need a lot more work. In fact, my research on TBI focuses on one of those potential biomarkers called S100 beta, which is a protein that, going back to the astrocytes that we talked about, right? One of the fire engines coming in, it releases this thing called S100 beta when it notices damage in the brain. So the idea is that if we were to measure this S100 beta in your cerebral spinal fluid, or in the blood, where it's almost impossible to measure, in your cerebral spinal fluid, that could be potentially a biomarker for someone that it could be, well, it's almost certainly a biomarker for concussion. And therefore, if you measure it over time, it may be a biomarker for CTE.
So, say argument's sake, they find a direct link with what is happening in the NFL. And of course, now the body of evidence at least seems to be growing. From, I think, Junior Seau may have been the first one to sort of commit suicide, and I think he was the first one who got his brain checked. And I think a lot of people will have watched the Aaron Hernandez documentary and seen that when they did a study of his brain, it turned out to be, they said they've never seen a brain of that age in such a young person. Tenuous links, like you said, there's nothing that can be proved. But when it does get to a point, just from your own standpoint, do you think that a sport and a body as powerful as the NFL, that it can actually stop, that it could actually be, do you think that it's just too big to fail, like one of those things, if it ever did come to that?
That's a great question. I don't know. I think there's American football is entrenched in this culture the way cricket is entrenched in our culture back home, right? I think Americans tend to have a desire to be very there's a pushback against anything that's feminine in men, right? Very, very, very masculine, very, very aggressive. Those are, every second person on the street has a gun, right? They're obsessed with violence in a weird way. They have this weird, complicated relationship with violence.
Have you got a gun yet under your mattress?
No, absolutely no. The data with guns is something we should get into someday. But
I mean, I love this argument. It's what? Guns don't kill people. People kill people. I love that.
I swear there's so many.
Yeah.
Just the skepticism of data and evidence in this country is something I've never experienced before. It's definitely, India has its problem with pseudoscience a lot, right? Yeah. The skepticism people here have of science is crazy to me. So anyway, in terms of the NFL, I think it might be too big to fail. There's some evidence suggesting that the number of kids playing football has reduced in youth football. However, what we don't know enough to see whether that means it'll reduce in high school and college. And
they are changing the rules, saying you can't tackle, you can't lead with your helmet. They're trying a lot of different things. With the quality that there's a lot of focus on the helmet itself and trying to keep that protected. But now I'm seeing that this is worrying a lot of people in a lot of different areas. Like, I think even now getting back to soccer, as you call it, or football, I was reading somewhere that in Scotland, they've banned heading the ball for kids under the age of 14 or something. It might be. I need to pull up the exact stats on that. And I know you said there's no correlation really to that, but obviously it's concerning people or parents or something. And they're like, we better err on the side of caution.
Yeah, definitely. In America, for 2-3 years now, the United States Soccer Federation has basically said no heading until the age of 10. And then you do a little bit of light heading. When you get to the age of 14 is when you can start to head the ball at full contact pace.
Light heading.
I forget how they phrase it. Yeah, light heading sounds really weird, right?
Light heading.
So it's a little light heading. I think you're only allowed to head in practice or something like that, I think is what it is for when you're between 10 to 14. Again, I may have that wrong, but the details that is. So the problem I have is, first of all, there's actually no evidence, by the way, that a properly headed ball can produce a concussion. The majority of the concussions in soccer, in football, come from head-to-head impact, head to elbow, head to knee, head to post. In the case of goalkeepers, right, they often hit the post. So those are the primary areas of concussive diagnosis and concussive implementation. However, what I worry about with this recent decision by the USSF is when you're in your early stage, when you're younger, you're not hitting the ball very hard. So it's actually good to learn how to head when you're 6, or at least the principle of it, 6, 7, 8 years old, because you just can't kick the ball hard, right? What I'm worried about is you're going to get to 14 years of age and now you have full contact heading. You'll have kids that have never developed the neck muscles to learn how to head, never developed the proper technique of hitting the ball. The hyperbolic shape of how the ball travels from a free kick, right?
I mean, I still can't hit a ball properly, so I know what you mean.
You can't play soccer properly. That's an entire conversation, Jhala. You should retire because it's really embarrassing to be on the pitch with you.
I tell you now, during these Corona times, I have gone and played football once or twice. It's
amazing, right?
Oh my God, I can't even explain to you that feeling of just being out there. And it's too good.
Dude, it's amazing. Honestly, like I in the interim of me moving to the States, my family moved to Delhi. So now when I come back to India, I'm in Delhi most of the time. So one of my favorite memories was the first time I came back to our Delhi home, which was 2009 when we met up. Was playing soccer with you and all those guys, right? It's such an important part of our lives. It's so great.
I feel like you and I could just have a full conversation about the merits of team sport and camaraderie and what that feeling is like, man. I could talk for hours. Had a very interesting conversation with Sunil Chhetri, I remember, about that. But this could go many different ways.
Nice little name drop. I'm not a humble brag. Sunil Chhetri. I was hanging out with Sunil and Cristiano the other day, and we were talking about the importance of the prick.
I played football with him as well and laid on an assist. He was on my team.
Was it just the two of you against an empty goal?
No. And we were playing against the team that had Mikhail Silvestre on it.
How did this happen? Have you never told me
this? And I was directly responsible for the 2 goals we conceded.
Okay, that part is a lot more believable.
It was a three-team tournament. There was Sunil Chhetri in one team, Mikhail Silvestre on another, and Robbie Fowler on the third. That's how I have my Robbie Fowler jersey signed behind me. There
that's
was a
amazing.
short stint I had with Mumbai City FC in
When-
the ISL. That's a whole other story. But Nipun, before we close this conversation, and seriously, man, this has been amazing. I don't know if I've cut you off too early and you have a billion other things to talk about, but I will be very honest that the reason that I've got you on this conversation is so that you could spend 60 minutes in the company of my brain and do a little bit of an analysis of what you thought is going on in there.
Like I said, Jali, I think there's a lot to unpack in there. I think there's a lot to figure out what the hell is going on in that brain, because I've wondered many, many times what keeps you ticking in the way that you do.
It's a special place, let's put it that way. We'll leave it at that. Nipun, man, doc.
Oh God, that's weird.
That is so weird, but appreciate it, man. Early in the morning, you're in Indianapolis. No, where are you? Yeah, you're.
Yeah, that's right. Yeah.
Indianapolis, man, crazy. And managing to connect during these Corona times. And I'm so glad that I'm doing this podcast because it's giving me that opportunity to reach out to people I haven't for a while. And
I think it's great.
And so talk to you in another 3 to 5 years.
Yeah, sounds about right, Jhala. We'll come up with some sort of podcast in 3 to 5 years. But genuine pleasure, man. It's so good to talk to you. And, like I said, you're doing a great job with this.
Keep fighting the good fight. Keep working hard and making us all so damn proud in Calcutta, especially. And I need to know what's going on with Corona, man. So please update me on Facebook. All right, cheers, man. I'll talk to you soon. Thank you, Shanks, again for being the voice in my ear. And talk to you all in a bit. Thanks, guys.